Hello, this video will serve as a presentation and demonstration for the SNOL or Simple Number Only Language Interpreter project by a group of third-year students from BS Computer Science, namely Limpag Hanna, Rapal Emmie Lou, Sijera Andrae, and Toñacao Thea Beatriz, in compliance to the adjusted course requirements on ComSci 124, Design and Implementation of Programming Languages. Before anything else, let me provide you with a brief description of what SNOL is. SNOL, which means Simple Number Only Language, is a simplified custom language that only involves integer and real values, operations, and expressions that performs basic arithmetic operations. In this project, SNOL is implemented using the C++ programming language. To explain better, we will show a quick run of the program. Here is the C++ code written collaboratively by the team to implement the Simple Number Only Language Interpreter. Details about the header used, global variables, and functions can be found on the documentation file. To show you how this interpreter works, let me perform a sample run of the program. At the start of the interpreter run, an introductory message is displayed. Now let us try to input the assignment operation command into. In this example, the keyword into is followed by the destination variable num, then followed by the keyword is, then an expression. Particularly in this example, our expression is the integer 0, which is assigned to the variable num. If we use the print command on the previously declared variable, it will display its value. Now let us apply the input operation beg on the variable var. Now, let us try to use the add command between an integer and an undeclared variable. As you can see, the program detects it as error, as the variable is not yet defined. Now, let us try to perform addition on the variable num and a float number 1.5. As you can see, it displays an error message because the num was previously declared as an integer, while the other operand 1.5 is not of the same type. Now let us convert the num variable into a float type by using the input operation beg. To do this, let us assign a float value on the num variable. By now, we can perform addition between the variable num and the value 1.5. Now let us try to perform the arithmetic operation add by giving a command that is not recognized by the language. As you can see, an error message displays as it does not match any valid command of the language. Let us check the current value of num. As you can see, the value remains the same even after the command add. That is because the arithmetic commands only performs the arithmetic operations between the two given operands. It does not reassign the result of the operation to the variable. Let us try to perform the arithmetic operation add followed by the input operation beg. As you can see, an error message appears because we're trying to perform add with an invalid operand. Now let us type into the command the assignment operation into and apply it on the variable num and assign it with a value coming from the result of an arithmetic operation add between two operands 2 and 3. We can see here that if a print is followed by a numeric literal, it prints the numeric literal. Now let us check the current value of num. As you can see, the value of num is already 5 after assigning it the result of the arithmetic operation add between 2 and 3. Now let us try the arithmetic operation div between 3 and 0 as a divisor. An error message occurs because the result of a 0 divisor is undefined. Now let us try using the modulo operation between two floats. As you can see, an error occurred because for the modulo operation, only integer type is allowed to be used for both operands. Let us try using the assignment operation into with the supposed to be value 0.2. It appears error because 0.2 does not follow the BNF rule for floating point. It should start with 0, then the decimal point. Now let us try performing beg by declaring a variable mult. This appears to be error because each of the keyword for the assignment, input, and output operations does not evaluate to any value value when executed. If you try to input a previously declared variable name in the command, it will not display error because it is simply specifying a simple expression. And lastly, invoking the exit command will terminate the program execution. That ends the sample demonstration of the SNOL interpreter. For further details of the project, please see the file of the documentation on creating the project and the source code file.